Hello everyone, this is week 11 Monday and we are looking at the critical path method or CPM and the project evaluation and review technique or PERT. Both of those are a part of project planning algorithm that have been developed in the 50s and has improved since then. So the algorithms is used in planning large-scale projects, in what order to execute the activities so the project can be completed within a minimum time frame and at a minimum cost. So to show in what order we need to execute the activities, we can just create a simple graph where the vertices would be the activity and the arrows between them or the edges will represent which activity is done after each of the other activities. So I'm just putting the names of the activities on the screen and I kind of put them in order that they appear and closer to its predecessor. So looking at the table, we see that A is the first one. It doesn't have any predecessor. And then looking at B, it has A as its predecessor, so we would put an arrow from A to B. So looking at C, it also has predecessor A, so we'll put an arrow from A to C. And we will keep going, so the next one is gonna be D, and it has B as its predecessor. Then E has C as its predecessor, so we'll put an arrow between from C to E. The next one is F, and it has two predecessors, D and E, so we'll put two arrows, one from D and one from E, pointing at F. And the last one is G, which has B as its predecessor. So this is a simple graph that can show us in what order we need to complete the activities. However, it doesn't show us how long we will need to do the activity, or do we have any wiggle room to start any of the activities. That's why we will use a more complicated note that has start date, late date, activity, how many days it takes, and the earliest possible finish and the latest possible finish for each of the activities. And I plug those into an Excel spreadsheet, and we'll see how we can create the critical path method and the project evaluation and review technique charts. So let's start populating our node. In the very first cell, we will put the early starting date. And as you can see in the second cell, I have the name of the cell. Under that, we're gonna put the duration, which for A is 5 days. And in that cell, we put the latest finish, which is 0 plus 5 would be finishing day on the 5th. So I'll just copy this cell and duplicate it to make all of the other cells. So our next cell would be B, and it will start right after A is finished because A is its predecessor, so it can start on the 5th, and it takes 5 days. I'm sorry, it takes 4 days, so it will be done on the 9th. and I'll fill in the other cells later. After B, we have C that has A as its predecessor as well. C can start on the 5th, and it takes 5 days. So C would be finished by the 10th. The next cell we have is D, and its predecessor is B, so I'll put it right next to B. And D can start as early as B's finish, which is the 9th. And D takes 6 days. So that means that D can be finished on the 15th. After D, we have E, and it has C as its predecessor, so I'm putting it close to C. And C finishes on the 10th, so we can start E on the 10th. It takes 3 days to finish. So that means it can be done on the 13th day. The next cell that we have is F, and it has two predecessors, D and E, so I'll put it right next to both of them. And it can start as early as both of its predecessors are finished, which means that we can start it as early as the 15th day, because E finishes on the 13th, but D finishes on the 15th. The duration of F is 4 days, so we can finish it by the 19th. And our last node or activity we need to put is G, which has B as its predecessor, so I'll put it right up here. And we can start G on the 9th day because B is finished on the 9th. It takes 3 days for G. So that means we can be done by the 12th day. So we populated all of the knots. Now we'll need to connect them with the arrows or the edges. So from every predecessor, we are putting an arrow to the next activity. So we have A as a predecessor of B, so we are putting an arrow, the same as A to C. The next one, we are looking at D has B as its predecessor and G has B as its predecessor. So from B there would be two arrows pointing out to B and G. And the next one, E has C as its predecessor, so there would be an arrow from C to E. F has two predecessors, D and E, so we need two arrows pointing towards F. And this is all. So we have our chart completed. Now we'll need to put in the late start date and the late finish date to populate each of the node cells. And how we will do that, we will look at the latest day that any of the activities can be finished on. So as we can see, 19th day is the last day the latest day. So it will take 19 days at most to finish the whole project. And we'll change the color of that cell to show the critical path. So we look at the predecessors of cell F, and this is D and F. And since D has the latest third date, that would be on the critical path as well. And F can be finished earlier, so it's not on the critical path. Then we look at the predecessors of D. It only has B as its predecessor, which means that B would be on the critical path, and we'll color it in the orange color as well. And the only predecessor that B has is A, and that's why we'll color it in the critical path color. So anything that is in orange is on the critical path. It needs to be started and finished as soon as its predecessor is done. Now we'll be looking to find the total float and the free float. So how we do this, we look at the latest finishing date, which is the 19th, and we work backwards. So if we finish on the 19th, that means we need to start F on the 15th. Then we move to its predecessors. So both of its predecessors need to be finished on the 15th, the latest, which would mean that D needs to be started on the 9th, but E can be started as late as the 12th. So that gives us a little wiggle room on E. So now looking at B, we see that we have not completed G, so we cannot do B yet. G doesn't have any and that needs to be done afterwards. So G can be finished on the last day, which is the 19th, which means that G can be started as late as the 16th day, which gives us some free float for G. Again, looking at B, we find out that because of D, B needs to be finished by the 9th day, meaning it needs to be started by day 5. Looking at C, it only has E after it, and we don't need to start E until the 12th day. So we can push back C until the 12th, which means we can start C by the 7th day. And again, looking at A, we see that because of B, A needs to be executed by day 5, meaning it needs to start by day 0. So this is the completed graph. Now we'll calculate the total float and the free float by comparing the early finish and the late finish date. So the difference between those would give us the number, and 19 minus 19 is 0, so we don't have any free float for F. Going over to G, we have the free float available because it's not on the critical path, and as we can see, 19 minus 12 is 7 days for G. Going over to D, we see that we have 15 and 15, so there will be no free float, or that would be 0. Going to E, we have 13 and 15, which gives us a difference of 2 days that we have a wiggle room to work with. Then going to C, it's again not part of the critical path. There's a wiggle room, and it is 2 days, the difference between 10 and 12. B and A are both on the critical path, so for both of these, there will be no wiggle room, and both would have a 0 value for the free float or the critical float. So we're finished with the Gantt chart, and we'll continue to figure out how many bulldozers we'll need to use in order to complete the task. So for day A, we can see that we need 5 days. So I'll just highlight 5 cells. And for each of those days, we need 3 bulldozers. So I'll put the number 3 in each of those cells. Then we know that B has A as its predecessor. So right after A finishes on the 6th day, we can start B. It will take 4 days. So we highlight 4 cells and we'll put 2 bulldozers in each of the cells. For C, we know that C starts right after A, which means we start on the 6th day and we need to highlight 5 cells. And each of those cells with 1 bulldozer. Now D starts right after B, so we can start it on day 10. And for D we need 6 days. So we are highlighting 6 cells. And we need 2 bulldozers for each of those days, so we'll be putting the number 2. The next activity that needs to be completed is E, and E starts right after C. So on day 11th, and for E we need 3 days and 2 bulldozers. The next activity is F. And F needs to start after D and E. So that means we can start it as early as the 16th day, right after D. And for this one, we'll need 4 days and 1 bulldozer for each of those days. And our final task is G, that starts right after B, which means day 10. It takes 3 days and 2 bulldozers. So I don't need any of those activities after G. I'm just gonna remove them from our chart. And now we will find out the total number of bulldozers we need each day by summing up each of the columns. So I will use the sum function and just select the column of the activities A through G. So in the column we only have 2, and then I'm just dragging the sum function all the way to the 19th day. And as you can see, we have all of the days, how many bulldozers we need, with the maximum of 6 bulldozers on day 11 and 12. So usually we don't know how long an activity would take. That's why we would be using a formula that kind of predicts the expected duration in the PERT model. So this is the formula: E equals O plus 4A plus P, the whole thing divided by 6, where O is an optimistic duration for the activity, A is the average duration of an activity, and P is a pessimistic prediction. Let's look at example 0.0.5. I plugged all of those values from the table into an Excel spreadsheet. And let's start populating our nodes. So we have A as our first node. It has no predecessors, which means that it will have a starting day of 0. It takes 3 days to complete. That means that the early finish would be on day 3. And now we'll copy A and make another node that is the second node, which would be B. And B has A as its predecessor. That means that B needs to start right after A on day 3. It takes 4 days to complete B, which means that it can finish the earliest on the 7th. The next one is C, and it also has A as its predecessor, so I'll put it right under B. And C starts as soon as A is finished, which means day 3. C takes 2 days, which means early finish on the 5th. And then the next cell we have or not to put is D, which has B as its predecessor, so I'll put it close to B. And it needs to start on the 7th because this is day 7 is when B finishes. D takes 5 days to complete, which means that early finish for D would be day 12. The next one is F, and it's right after C, so I'll put it next to C. And then E starts on the 5th, right after C is finished. It takes 1 day, so it will be done by the 6th. Our next node would be F, and it's after C, so I'll put it right here. It needs to start on day 5, and then it takes 2 days to complete, which means the early finish would be on the 7th. And our next one would be node would be G, which has 2 predecessors, D and E, so I'll put it on the top close to them, and it needs to start on the 12th because between 6 and 12, 12 is the bigger number. So right after D is finished, it can start. G takes 4 days, which means that would be done by the 16th. Our next one is H, and it's right after F and G. So I'll just put it close to F and G. And that one needs to start after both F and G and finish, which means the 16th. And it takes 3 days to complete, which means day 19 would be its finishing day. And the last cell that we have is I, which is right after C. So I'll put it under C. And it can start right after C on day 5, and takes 3 days, so would be done by the 8th. So we put all of our nodes. Let's just put the connections between them. So we know that A is a predecessor to B and C. So we'll connect A to B and C. The next one, D has B as its predecessor. E has C as its predecessor. And also F has C as its predecessor. Then G has two predecessors, D and E. So we'll have two arrows pointing to G. And the same with H. H has predecessors F and G. So we'll have two arrows going into H. And our last node is I, having C pointing at it. So now we'll look at the latest date that the project can be finished on, and this would be the 19th day for H. So H would be our last task, and it will be on our critical path, so we'll change the color of H. So now let's look at H's predecessors. We have G, which finishes on the 16th, and this is the day that H needs to start, so definitely G would be on the critical path. And let's also, because of the 16th, if we look right here, it's the 16th day that G needs to be finished by, whereas F can be finished on the 7th, so it can have different finish dates between the 7th and the 16th. That's why F is not on the critical path. So looking back at the predecessor of G, we have D on the 12th and E on the 6th. So based on those two numbers, we see that D would be on the critical path, and we'll highlight it. Looking at this predecessor, we only have B, which means that B would be on the critical path, and A is the only predecessor for B, so we are highlighting A as well for the critical path. So anything that is in orange is part of the critical path, and anything that is in green is not and has some wiggle room. So let's look at the total and the free float. So the latest day is the 19th that H can be finished. So that means that H can be started the latest on the 16th. So looking backwards, for F, we can finish it as late as the 16th because we don't need H until the 16th, meaning that F can be started as late as 14th, which is not the case with G. If we start on the 16th, on the 12th, we need to finish by the 16th. There is no free float between those two. So now looking at the predecessors, D needs to be done by the 12th, the same as Z, which gives us starting dates for D on the 7th and for E on the 11th. Now looking at I, it has nothing that needs to be done afterwards. So it can be finished on the last day, which is the 19th, which means that it can be started as late as the 16th day. So now if we look at C, we see that the latest C can be finished on is the 11 day because of E, and then the other just can start anytime later. So the 11 day for C to be finished, and that means that it can be started on the 9th. B is on the critical path, so we need to finish it by the 7th no matter what, and that means starting it on the 3rd, and the same with A. It needs to finish on the 3rd because B needs to start on the 3rd, and start for A would be on the day 0. So now we would complete our Gantt chart, which would give us the total number of workers that we need for each of the days. And we know that activity A would take us 3 days, so we are highlighting 3 cells. And for each of those days, we need 2 workers, so we're putting number 2 in. Activity B starts right after A, so we can start it on day 4. And that takes 4 days, so we are highlighting 4 cells and putting 3 workers in each of those cells. Activity C starts right after A, which means day 4, and it will take 2 days and 2 workers for each of the days. Then activity D would take 5 days and 4 workers right after B, so that means day 8, and 4 workers for each of those days. Next activity is E, and it starts right after C, which means day 6. It lasts 1 day and it requires 4 workers. So next activity would be F, and for F we start right after C. We're highlighting 2 cells for duration of 2, and we put 1 worker in each of those cells. The next activity would be G, and G needs to finish after F and E, which means that we need to start on day 13 right after D is finished. That activity would take us 4 days, and we need 3 workers on each of those days. Then we need to do H, which takes 3 days, 1 worker on each day, and it starts on day 17, right after D and E are completed. And our last activity is I, that starts right after C. So C is right here. We can start then on day 6, and that takes 3 days and 4 workers. So we have completed the chart. Now we'll need to check out the total number of workers that we need for each day. And we'll do that by summing up the number of workers per day for each of the activities. So basically we are summing up the column from A to I for each of the days. So I'm just dragging the formula all the way to day 19. And as you can see, we have the most employees on day 6, and the most number of employees is 11. So we'll see if we can use any of the green colored nodes or activities that we can move around and see if we can use less workers per day. So looking through those, we notice that C, I, E, and F are the activities that we can move around. I just realized that I did not do the free float and the total float to know how many days I can move each of the activities, so I'm just gonna do this very quick by subtracting the early finish and the late finish for each of the activities. So 12 minus 12 is 0. 40. 12 minus 6 is 6. 3. For F, we have 16 minus 7, which gives us 9 days that we can move F around between starting on the 5th or starting on the 14th. Then looking at B, we only have 7 minus 7 for the early finish and late finish, which would give us just a 0 for the free float for B. For C, we have 11 and 5, which would give us a free float of 6. Looking at I, we have 19 and 8, which would give us a free float of 11 days. And for A, we have 3 minus 3, which would give us a free float of 0. So now based on those numbers, we can see if we can move some of the assignments that are not critical and take those activities to days that we don't have as many workers involved. So we don't have 11 workers on day 6. And those would be any of the green activities that we can move around. So let's see which one of the activities on day 6 we can move around. So we have B, E, F, and I. So out of those, we see that we can move F, E, C, and I. So let's see if we move F, we can move it as late as starting on the 14th and ending on the 16th. So let's see if we do that, if we can improve the time. Okay, so we moved it a little bit and we have now 10 workers on this day, which is better than what we had before. Let's see what else we can do to improve the number of workers. We see that I can start as late as day 19, so let's move it all the way at the end, and that gives us only 6 workers on day 6, which is much better than the 11 that we started with. Let's see if we can do anything else. Can we move E? We can move E 6 days, which means that it can go as late as being on the 12th. However, that would put more workers either between the 8th and the 12th, and this number would go more than 6 because as of right now we have either 4 or 5 workers on those days. So it looks like this is the best that we can do with the number of workers Gantt chart as of right now. Let's look at week 11 Monday assignment. So it is very similar to what we have been doing in the previous assignment. It just has a bigger table which I will plug in into Excel and we can start working on. So let's start plugging the values into our nodes. We know that A starts on day 0, it takes 2 days, so it will have an early finish on day 2. And now the next cell that we need, or the next node, is B, and it has A as its predecessor. So I will just copy A and put B right here. And we know that B starts right after A, which means that it will start on day 2, takes 3 days, and be completed on day 5. Then we have C that starts on day 5, right after B. Then C takes 4 days to complete, and C would finish on day 9. And then we see that C is a predecessor to 3 cells, D, E, and F, so I will put those down. And let's fill in the starting and duration and ending day for those cells. So for D, we have starting as soon as C is finished on the 9th. D will take us 4 days, which would give us total of 13 days to finish. Next one is E, and it will start on the 9th as well. Takes 2 days and be finished on the 11th. And after that we're gonna do cell F, and F starts on day 9, takes 2 days and finishes, oh I'm sorry, I messed up on E, so 1 day finishes on the 10th, and F takes 2 days and finishes on the 11th. So looking back at the chart, we're finished with F. The next cell would be G, and it comes right after E. So I'll paste it close to E. And we know it finishes as soon as E is done, so that would be day 10. And for G, we have a duration of 2 days, so it will finish on the 12th. The next one would be H after F. And it will start as soon as F finishes, 11th, and H would take 3 days. So that means H would be finished as early as day 14th. The next one would be I after F. So I'll put it under here. Which means starting on the 11th, I is taking us 1 day, which means would be completed as early as day 12. Okay, what else do we need? We need J after B, so I'll just position it right under B. That would start on day 5, right after B, because B finishes on the 5th. J also takes 2 days, which means J would be completed by day 7. And our last one is K, right after D, so I'll put it right here on the top. So it will start on the 13th. It will take 3 days to complete, and it will be finished by the 14th. So we have completed all of our knots, and we'll need to connect all of them now. So B has A as a predecessor, we'll connect A to B. B is a predecessor of C, so we'll connect B to C. And then C has 3 activities that follow it, which are D, E, and F. After that, G has E as its predecessor. And F is a predecessor of H and I. We have J has a predecessor B, and D is a predecessor of K. So now we have all of the connections, and we'll start to work on the backtrack algorithm. So the latest date that we can finish an activity is the 16th for K. So that's why I will highlight K in a different color and see how we can work backwards to find our critical path. So D is a predecessor to K. C is a predecessor to D, so we'll need to highlight C, and working backwards, we'll need to highlight B as well as A. So now our critical path is marked in blue, and anything that is marked in green has some wiggle room that they have a free float that we can compute later. So let's see what is the latest finish date. So we start with the 16th. And anything that doesn't have any activities followed can be finished as late as the 16th. So we are putting those in. And we will start working backwards. So K needs to be started as late as the 13th. G can be started as late as 16 minus 2, 14. H can be started as late as 16 minus 3, the 13th. I can be started as late as 16 minus 1, the 15th. So based on those late starts, we see that F needs to be started no later than the 13th because of H. So the latest start of F is the 13th. which means that F can be started as late as day 11. Looking at F, it can be finished as late as the 14th, and it can be started as late as day 13. D, because it's on the critical path, it needs to be finished on the 13th and started on the 9th. So now looking at C, it has 3 following activities, but 9 is the earliest date. So working backwards, we can fill in B and A, just because they're on the critical path and we know that they don't have any wiggle room. Whereas I, we have a wiggle room and we can start it as late as the 14th day. So now based on those two numbers, we can put in the total float and the free float by subtracting the early finish date from the late finish date. So for K, that would be 0 just because it is on the critical path. For G, we have 16 minus 12. That gives G a wiggle room of 4 days. For H, we have 16 minus 14, which gives us 2 days. For I, we see 4 days again. D has no wiggle room because it's on the critical path, so no free float. It is 0. For E, we have 14 minus 10, which gives us 4 days of free float. For F, we have 13 minus 11, which is 2 days of free float. 0 days for C, 0 days for B, 9 days for I, and 0 days for A. So now we can complete the Gantt chart. That would give us how many days, how many workers we need each day. So we know that A has no predecessor, so we start on day 1 and it takes 2 days and 3 workers for each of the days. For activity B, we started right after A and it takes 3 days. And it also takes 3 workers per day. For activity C, it starts right after B and it takes 4 days and 5 workers for each day. Activity D starts after C and for total of 4 days and 5 workers for each of the days. Then activity E is after C again. It only lasts 1 day and it needs 2 workers. Activity F again starts after C, so we can start it on day 10 and it will take 2 days and 2 workers. Activity G is after E, which means we can start it on day 11 and it will take 2 days, and 5 workers for each of the days. For H, we have starting after F, okay, which means day 12, and it will take us 3 days and 3 workers. For activity I, we start after F, and then that would be 1 day and 2 workers. For activity J, we have right after B, so we can start this on day 6. It takes 2 days and 2 workers. And for activity K, we start right after D, which would be day 14th, with 3 days and 3 workers for each of the days. So based on the Gantt chart and also on the graph above, we see that we only need 16 days to complete the activity. So I'm just removing the extra days that I had on the table, and to find the number of workers, I'm using the sum of each column that has the activities in it. So as you can see, for day 1 I only need 3 workers, but let's see what we need for the other days. So as we can see, on day 12 we have 15 workers. So let's see if we can move some of the non-essential work or non-critical work around, and we can lower the number of workers on day 12. So we can do this again by moving any of the green colored vertices or activities. So we have those as J, F, E, and G. So let's see. G can be moved as late as day 16. So let's see how it will work out if we move it later. To day 15 and 16. So that improved day 12. Right now at day 12 we have 10 workers. Let's see if we can improve this maybe a little bit more. So we have D, which is essential. We have I, which is not essential, that we can move to a later date. So we can move I anywhere up until day 16. However, if we move those 3 and add them to the 8 on the 15th and 16th day, it will give us 11 workers on day 15 and 16, which is more than 10. And I don't think this would be a good idea. Let's see if we can move those two over here to day 14. Oh yeah, so that gives us maximum of 8 workers on day 12 and day 13, 14, 15 and 16, which is much better than what we started with. So that was week 11 Monday, the CPM and PERT algorithm, and also the week 11 assignment. Thank you for watching and have a nice day.